Biofuels, powering the future with nature's energy. In a world increasingly defined by the urgency of climate change and the search for sustainable energy, biofuels have emerged as one of the most promising alternatives to fossil fuels. Derived from organic materials such as plants, agricultural waste, and even algae, biofuels represent a bridge between modern energy demands and the natural processes that have sustained life on Earth for millions of years. At their core, biofuels are built on a simple yet powerful idea: using recently living biological matter, known as biomass, to produce energy. Unlike fossil fuels such as coal, oil, and natural gas, which take millions of years to form, biofuels can be produced relatively quickly and replenished through agriculture and natural cycles. This makes them a renewable resource, offering hope for a more sustainable energy future. The most common types of biofuels today are bioethanol and biodiesel. Bioethanol is typically produced by fermenting sugars found in crops like corn and sugarcane. It is widely used as an additive in petrol, reducing greenhouse gas emissions and improving fuel efficiency. Countries like the United States and Brazil have invested heavily in bioethanol production, integrating it into their transportation systems. Biodiesel, on the other hand, is made from vegetable oils, animal fats, or recycled cooking oil. It can be used in diesel engines with little or no modification, making it a practical and accessible alternative for existing vehicles. One of the key advantages of biofuels lies in their potential to reduce carbon emissions. Plants absorb carbon dioxide from the atmosphere as they grow, and when biofuels are burned, they release this carbon back into the air. In theory, this creates a closed carbon cycle, resulting in lower net emissions compared to fossil fuels. However, the reality is more complex. The production of biofuels often requires significant amounts of land, water, and energy, which can offset some of their environmental benefits. This has led to an important distinction between first-generation and advanced biofuels. First-generation biofuels are made from food crops such as corn, wheat, and sugarcane. While effective, they raise ethical and environmental concerns, particularly regarding food security and land use. Converting large areas of farmland to fuel production can drive up food prices and contribute to deforestation. In response, scientists have been developing second- and third-generation biofuels, which use non-food sources like agricultural waste, wood residues, and algae. Algae-based biofuels, in particular, have captured the imagination of researchers. Algae can grow rapidly, require less land than traditional crops, and produce high yields of oil suitable for fuel. Moreover, they can be cultivated in environments unsuitable for agriculture, such as saltwater or wastewater systems. While still in the experimental stage, algae biofuels could revolutionize the industry if production costs can be reduced. The development of biofuels is closely linked to broader efforts to combat climate change. Governments and international organizations have introduced policies and incentives to encourage the use of renewable energy sources, including biofuels. In the European Union, for example, renewable energy targets have driven significant investment in biofuel technologies. Similarly, countries around the world are exploring ways to integrate biofuels into aviation, shipping, and heavy industry, sectors that are particularly difficult to decarbonize. Despite their promise, biofuels are not a perfect solution. Critics argue that they can lead to unintended consequences, such as habitat destruction, water shortages, and increased use of fertilizers and pesticides. There is also ongoing debate about their overall efficiency and scalability. Can biofuels truly meet global energy demands, or will they remain a supplementary solution alongside other renewables like solar and wind power? What is clear, however, is that biofuels will play a role, perhaps a significant one, in the transition to a more sustainable energy system. As technology advances and new methods of production are developed, the efficiency and environmental impact of biofuels are likely to improve. The challenge lies in balancing innovation with responsibility, ensuring that the pursuit of cleaner energy does not come at the expense of ecosystems or food security. In many ways, biofuels represent a return to nature, a recognition that the solutions to our most pressing challenges may already exist within the living world around us. By harnessing the energy stored in plants and other biological materials, we are not just creating fuel, we are reimagining our relationship with the planet.